Hi, everybody. I'm Mr. Lineberger, and I'm glad I'm finally here. What a day. My mother and I have entered a family hiking challenge. All the families who enter agree to hike 10 miles in just a single weekend. 10 miles is a long way, but we don't have to do it all at one time. Anytime I'm out for a hike, I can record how far I went, and that distance counts towards our 10-mile goal. I'm gonna go stash this at the campsite. Give me a second. I'll be right back. Okay, I'm back. I just got finished with a long hike, and I want to figure out the total distance that my mother and I have walked. Let's see. My mother sent me a text yesterday. She hiked for 5 2/3 miles. Knowing my mom, it was probably uphill the entire time. Today, I hiked a gorgeous trail by the river, and I covered 3 3/4 miles. To figure this out, I'm going to need to add some fractions. So let's start with some easy examples before I tackle the real problem of the hiking challenge. Okay, I know that fractions have two parts, the numerator on top and the denominator on bottom. I also know that if the denominators are the same, adding fractions is easy because I just add the numerators together. For example, 1/4 plus 2/4 isn't hard for me to do since the denominators are the same. I just add 1 plus 2 to get 3. Put that over my denominator and my answer is 3/4. 1/4 plus 2/4 equals 3/4. Let's try another easy one. What if I had 2/5 plus 2/5? Same thing. Denominator is the same, so 2 plus 2 equals 4. The answer is 4/5. But what if the denominators are different? If that's the case, I have to make them the same and then add the numerators. If I had 1/4 and I needed to add that to 1/2, I would need to make the denominators the same. I can do that by drawing a picture. Here's a rectangle divided into 4 parts. Color one of those parts in, that's 1/4. Here's a rectangle divided into 2 parts. Color one part in, that's 1/2. But what if I divided those parts again? Now I have 4 parts and 2 of them are colored in. That means that 1/2 is the same as 2/4. Now I've got it. 1/4 plus 1/2, which is 2/4, equals 3/4. Here's another one. Imagine I'm supposed to add 2/3 and 3/4. Since the denominators are different, I'll have to create a common denominator. I'll use a picture to help me figure this out. Here's my rectangle that represents thirds. It's divided into 3 parts. I color 2 in, that's 2/3. Here's a rectangle to represent fourths. It's divided into 4 parts. I color 3 in, that shows 3/4. If I divide each block in my thirds rectangle into 4 smaller sections like this, I can now see that I have 12 sections total. And 1, 2, 3, 4, 5, 6, 7, 8 of them are filled in. 8/12. If I divide the sections in my other rectangle into 3 parts each, I also have 12 sections now. 1, 2, 3, 4, 5, 6, 7, 8, 9 parts are colored in. 9/12. To add 8/12 and 9/12, I keep the denominators the same and just add the numerators. 8 plus 9 is 17. So the answer is 17/12. That's a fraction greater than 1, and that's totally fine to have as an answer. I know that 12 twelfths is equal to 1. So, if I wanted to think of this as a mixed number, I could. It would be 1 and 5 twelfths. Let's try one last example. Imagine I have the problem of 1/2 plus 3/8. For my 1/2, I can draw a rectangle divided into 2 parts. Color one part in, that's 1/2. 3/8 is like drawing a rectangle, dividing it into 8 parts, and then coloring 3 of those in, like this. I can't just add these fractions because the denominators are different. So what if I take that 1/2 I already colored, and I keep dividing the rectangle until I have 8 parts? How many parts are colored in now? That's right. 4 parts are filled in. 1/2 is the same as 4/8. So I can rewrite my problem as 4/8 plus 3/8, and that equals 7/8. 1/2 plus 3/8 equals 7/8. I think I'm ready to tackle my hiking problem. But first, let's estimate a possible answer. I know that 2/3 is close to 1, so instead of 5 2/3 miles, I'll estimate that my mother walked 6 miles. I also know that 3/4 is close to 1, so I'll use 4 miles for myself. 6 miles added to 4 miles, that's 10 miles. Since I rounded up, I know the precise answer will be a little less than 10 miles. That's my estimate. My mother and I have walked a little less than 10 miles. Man, we almost made our goal on the first day. Okay, we need to figure out exactly how many miles we walked, so we'll know how many more we have left to do. There are a lot of ways I could solve this problem, but the way I'll choose is by finding a common denominator for my fractions. My mother hiked 5 2/3 miles. I can represent 2/3 like this, a rectangle divided into 3 parts, and I'll color 2 of them in to show 2/3. I hiked 3 3/4 miles. I'll represent 3/4 with a rectangle separated into 4 parts, and I'll color 3 of them. If I need to know the total number of miles we hiked, I can think of it this way. 5 plus 2/3 plus 3 plus 3/4. That's all the miles. My mom hiked 5 miles and also 2/3 of a mile. I hiked 3 miles and also 3/4 of a mile. 5 plus 3 is 8. So I know we hiked 8 miles plus 2/3 plus 3/4. If I partition my thirds into 4 equal pieces, I now see that I have 1, 2, 3, 4, 5, 6, 7, 8 of the 12 pieces filled in. If I separate my fourths into 3 equal pieces, I can see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces filled in. So that's 8 twelfths plus 9 twelfths, 17 twelfths. Together, my mother and I have hiked 8 plus 17 twelfths miles. That's 8 plus 12 twelfths plus 5 twelfths. Do you see how I did that? I know that any fraction where the numerator equals the denominator is the whole number 1. 12 twelfths is the same as 1. We hiked 8 miles plus 1 mile plus 5 twelfths miles. We hiked 9 5 twelfths miles. How does that check out compared to my estimation? I estimated that my mother and I had hiked a little less than 10 miles. 9 5 twelfths is a little less than 10. I think we've got the right answer. I wonder, how much farther will we need to hike? 12 twelfths minus 5 twelfths is 7 twelfths. That's slightly more than half a mile. I could do that right now. In fact, I will, as soon as this lesson's over. Today we determined that my mother and I are a good hiking team. We showed that adding mixed numbers was the same as adding whole numbers and the fractions. To add the fractions, though, we had to partition them into the same number of units, which is called finding a common denominator. And we learned that as long as the denominators are the same, the numerators can be added together. Well, time for me to get back to the trail. I'll catch you next time.